Alright, let's calculate some more derivatives. And yeah, this is going to be pretty calculation heavy, but we'll get through it. So, x to the power of y to the power of z. So what we're going to do here is we want to write this in a way that we can deal with, and so as usual this is going to be exponential of the natural log of x to the power of y to the power of z. And now, when we want to bring things down, note that x to the power of y to the power of z, y to the power of its x is being raised to the power of y to the z, and not x to the y being raised to the power of z. Because x to the y being raised to the power of z is the same thing as x being raised to the power of y times z, which is not what's happening here. So you got to keep that notation straight in your head. But because this is x to the power of y to the power of z, then when we want to bring down the exponent, we bring it down like this. The y to the z comes down, and natural log of x remains. It's not this as opposed to bringing down the z and having x to the y being what remains in the natural log. Okay, and now what we have to do if we want to reduce this further is we have to do sort of the same thing again. So we have to have the exponential of natural log of y to the z and natural log of x. So this is exponential of, and then here we're going to have the exponential of z natural log y times natural log of x. And so this, of course, is going to be the exponential of, and now we use the projection function. So pi 3 times natural log of pi 2 times natural log of pi 1. Okay, so this is a form that we want, and now we can take the derivative of f evaluated at a comma b comma c. So the first thing that we're going to end up with is you have to, when you take the derivative of the outside function, whenever you're doing an exponential, that just ends up being whatever you started with. And so we're actually going to end up with an a to the power of b to the power of c on the outside here, because the first step is going to be the derivative of the exponential function evaluated at exponential of pi 3 natural log pi 2 times natural log pi 1. And then you basically just undo all the steps that we just did above, and you'll get to a to the power of b to the power of c. And then we have to multiply this by the derivative of the inside stuff. And the inside stuff is the exponential of pi 3 natural log of pi 2 times natural log of pi 1 prime. That's an L and not in open parentheses. So yeah. So that's the first step. And now we go ahead and product rule. So it's the first term, and then the second term would be pi 3 natural log of pi 2 times, then we have the natural log of pi 1 prime. Well, actually, wait a minute. When we take the derivative of the exponential of blah, 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 what we're going to end up with is we're going to end up with the exponential of whatever times the derivative of the inside. So what we can actually do is we have a to the b to the c, and then we can actually pull out an exponential of pi 3 natural log of pi 2, and then so we pull that out of the sum, and what's going to be left on the inside here? So in the first term in the sum, the natural log of pi 1 is still there, and we also have to multiply by the derivative of what was on the inside of this exponential. So this is going to be pi 3 natural log of pi 2 prime times natural log of pi 1. Then we add, well, we've pulled out the exponential of pi 3 natural log pi 2. So this is just going to be the derivative of natural log of pi 1. And by the chain rule, that's going to be 1 over pi 1 times pi 1 prime. So we've got a to the b to the c. And now we can probably go ahead and deal with this. Let's see. So what's this going to be? So this is e to the power of c natural log of b. And now we've also got, okay, so now to take the derivative of pi 3 natural log pi 2, we have to use the product rule again. So we're going to get pi 3 prime natural log of pi 2 plus, okay, so this is going to be all in its own parentheses. Now we're going to get pi 3 times natural log of pi 2 prime. And this term is being multiplied by natural log of pi 1. And then to this, we're adding 1 over pi 1 times pi 1 prime. 1 over pi 1, well, that's just going to be, we can replace that with 1 over a. Then pi 1 prime is 1, 0, 0. Alright. So far, so good. So we've, again, a to the b to the c. Now, e to the c natural log b, this becomes e to the natural log of b to the c, which is just b to the c. Right? Yeah. Okay, so far so good. And then on the inside here we've got pi 3 prime times natural log of pi 2. So that's going to be 0, 0, 1 times natural log of pi 2 is just natural log of b. Alright? And then we've got pi 3 times natural log of pi 2 prime. So pi 3 is just c. The natural log of pi 2 prime, again, just like we did with natural log of pi 1 prime, this is going to be 1 over pi 2 times pi 2 prime. So it's 1 over b times 0, 1, 0, because that's the derivative of pi 2. Then finally, we have to add 1 over a times 1, 0, 0, which of course is 1 over a, 0, 0. Use brackets here again. So we've got a to the b to the c times b to the c times, let's see, we've got 0, 0 natural log of b plus 0 c over b, 0 plus 1 over a, 0, 0. So finally, we have a to the b to the c times b to the c times, then we're going to have 1 over a, comma, c over b, comma, natural log of b. This doesn't quite look right. This guy. I lost this guy. Okay, yeah, and that makes sense. Okay, so what we're going to have is this natural log of pi 1, that needs to go here. So this is going to be here. We're going to go natural log of a there, and we also have a natural log of a here. Got a natural log of a here, got a natural log of a here, and so finally this should be c over b times natural log of a, and this should be natural log of b times natural log of a. Okay, there we go. Okay, so my bad on forgetting about that guy. And so yeah. So that does part E, and then let's go ahead and do part F as well. F is sort of similar, it's actually a little quicker. We're going to have f of x, y, z equals x to the y plus z. And we do the same standard thing. This is the exponential of the natural log of x to the y plus z. And so then we can bring down the y plus z, natural log of x. And so this is going to be the exponential of pi 2 plus pi 3 times natural log of pi 1. So then from here, what we do is we take the derivative of f and we evaluate it at a, b, c. And so the first thing, again, because we're taking the derivative, because the outside function is the exponential, we start by just plugging in a, b, and c. And then we have to multiply by the derivative of what's on the inside. So we got I should skip to the next line because we're going to have to use a product rule here. Okay, so we're going to have pi 2 plus pi 3 prime natural log of pi 1 plus pi 2 plus pi 3 times natural log of pi 1 prime. Okay? And now what we do is when we take the derivative of pi 2 plus pi 3, derivative of pi 2 is 0, 1, 0. Derivative of pi 3 is 0, 0, 1. So the derivative of pi 2 plus pi 3 is 0, 1, 1. We multiply by the natural log of a. Then we're going to add b plus c and multiply by 1 over a times the derivative of pi 1, which is 1, 0, 0. So we've got a to the b plus c. And let's see, here we've got 0, natural log a, natural log a. And here we got b plus c over a, 0, 0. And so then our final answer, we're going to have an a to the b plus c out front. Then our first coordinate is going to be b plus c over a. Then we get natural log a, natural log a. And that's about it. So yeah, that's how you do parts E and F.